Alright guys, in this video I'll be teaching you the fundamentals of Roblox scripting. If you've never scripted before or are still new to it, this is the video for you. So to start off, we'll insert a script into server script storage. So first thing we want to cover is printing. Now, when we open a script, we see the infamous line, print hello world. Now, what does that line of code do? To run the code, basically what you want to do is go to test and run. As you can see, it prints hello world to the output window, which is this tab right down here. So basically print is a function that outputs whatever you place between the brackets to the output window, and it can print all kinds of data types. A data type is basically a way to classify the different forms in which information can be displayed. So you have your primitive data types like numbers or strings. Strings are basically text like this. Another data type is Boolean values, which are either true or false. And there are also more complex data types like instances, UDOM, and vector3 values, which we'll cover in a later video. With that out of the way, we can move on to properties. So properties are things that objects like parts and GUIs have that can change. So like size, color, position, transparency, just to name a few. And you can find the properties that an object has in the properties window. So if I had a part right here, I can go down to this properties window and see all the properties it has when I have it selected. Now to change an object's property, we have to locate its position inside the game. All things inside Roblox Studio are under what's called game. It's considered the parent of everything inside. And next down in the hierarchy are the services like workspace and lighting and so on. And finally, at the bottom of the hierarchy, we have the objects that are inside the services. So you can think of services as children of game. And the base plate, for example, since it's found inside of workspace, it is the child of workspace, and workspace is the parent of base plate. Now, if we want to change the properties of something, we'll have to use a script. So we'll go back to the script we opened before. And the first thing we have to do is we have to do what's called referencing. Basically what we're doing is we're locating the object whose property we want to change inside the game. We're finding its location. So we want to do game.workspace. The dot indicates that whatever goes after belongs to the term that goes before. So we know that workspace belongs to game. We do workspace because the part we want to change is found inside of the workspace. So we do game.workspace.part. And then since properties belong to the part, we add another dot. You can see a bunch of the properties that it has. So let's say we want to change the transparency. If you look in the properties tab, transparency is a value that goes between 0 and 1. So when I get closer to 1, it gets more transparent. So since it has a transparency of 0 right now, we'll increase the transparency to 0.75 so that it's almost completely transparent. And to test the code, we can go click run. You can find it either under the test tab or the script tab. So when we click run, it'll execute that code. As you can see, the part is mostly transparent now. You can barely see it over here. Another example I'll show you is the anchored property. Anchoring a part basically keeps it in its place. So if you had anchored, it will stay in the air without falling. But if it's not anchored, it will just fall out of the sky. So I'm just going to run it now with it being anchored, and you'll see that still floats in the sky. Anchored takes a Boolean value, so in order to change it, you do game.workspace.part.anchored, and instead of setting a number, you either say that it's true or false. True means it is anchored, and false means it isn't anchored. So if we want it to not be anchored, we'll assign a value of false to it. So game.workspace.part.anchored equals false. And when we run the code, it stops being anchored and it falls out of the sky. With that out of the way, we can move on to variables. So what are variables? Variables are just names that hold a value. So any kind of data type can be stored with a variable. So let me show you how to declare a variable. The first thing you want to do is type the keyword local and then your variable name. Let's say we want to store a name. So we can do local name equals scriptix. Basically what we're doing is we're creating a variable called name. So basically this equal sign is assigning a value to name. So whatever goes after the equal sign is what name will equal. And I put scriptx as a string. Whenever you reference the variable, it will give you the value of name. So we can print the variable to the output window. Basically what it'll do is it will print name, it'll look back to what value is assigned to it. It will see that the string scriptx is assigned to it, so it'll print scriptx to the output window. And it does exactly what we ask. To build off of what you just learned about properties, you can assign any object you want to variables. So I can do local part equals game.workspace.part. So what we're doing is we're assigning this part that we have here in workspace to this variable right here. So instead of retyping game.workspace.part every single time, we can just do part dot whatever property we want to change. So part dot anchored equals false. So instead of retyping game.workspace.part every single time, we can just use the variable name, and it'll know that we're referencing the part that's inside workspace. So when we run it, it executes the code correctly, and it saves you a bunch of space, and it makes your code look way more organized. With that out of the way, let's move on to functions. What are functions? Functions are blocks of code that are executed when you call it. Say you had a really long piece of code that you need to use over and over again. Would you copy and paste the entire thing every time you need to use it? No. You would make a function and call it. By calling, I mean you're telling it to run. So let's make a function that adds two numbers together. So the way you define a function is that you use the keyword local and then type function. Now you need to create a name for your function. So since this function's purpose is to add numbers, we'll call it add number. After that, use a set of brackets and then press enter. And notice how it adds the word end at the bottom. You need to have that when you're making functions. So local function, your function name, followed by two brackets, with the keyword end at the bottom. So in between the first line and the bottom line is where the function will be. This is the code that will be executed when you call it. So let's say we want to add the numbers 3 and 2, which makes 5. We can store it in a variable and then print it out. So we can do local result. So we're creating a variable called result, and we're assigning it to the sum of 3 plus 2. And the last thing we want to do is we want to print the result to the output window. Now when you want to use the function, you need to call it, and you call the function by typing the function's name followed by the brackets. If we didn't have this line here, it wouldn't print anything at all because all you've done is define the function. But by calling it, you're executing the code that's inside this block that's in here. So we'll run the code and we'll see if it prints out 5. And it does. Alright, but what if you needed a function that would change the output depending on the situation? So if we needed to add numbers, we could use the function we wrote over here. But what happens if we need to add different numbers every single time? That's where parameters come in. So parameters serve as variable placeholders, which get assigned values when the function is called. So parameters go in between these brackets over here. You can name them anything you want. Treat them as variables without a value assigned to it. So we'll call it num1 and num2. So there's two parameters separated by a comma. So these two parameters will represent the numbers that we'll add together. Now when you're calling a function that has parameters, you also have to specify arguments. Arguments are information that you send to the function. So in this case, we're sending two different numbers we want to add together. So let's say 5 and 4. And remember what I said about the parameters being placeholders? Well, when you call the function, num1 gets assigned whatever value you passed on as the first argument. So in this case, num1 will become 5, and then num2 will become 4. The last thing we want to do, we want to modify what the result equals. So instead of adding 3 and 2 together, we want to add num1 and num2 together. So when we call this function and we pass the values of 5 and 4, num1 equals 5 and then num2 equals 4. And then the result adds the two numbers together. So 5 plus 4 equals 9. So let's run it and see if we get 9. And it does. And you can change the arguments whenever you want. So you can change it to 10 and 7. And you wouldn't have to change the actual function itself. You just have to change the arguments. So when we run that, it'll take 10 and 7 and it'll add it together and it'll get you 17. Great, so now we can add any numbers that we want using the same function. So what if we want to use the answer instead of just printing it out? Could we like add 5 to the answer? So could we do result equals result plus 5? We'll run that and we'll see. We get an error here because we're trying to add a number with a nil value. A nil value just means it has no value. So you can't add nothing and 5. And the reason it's nothing is because result is a local variable, so it only exists within the code block in which it's defined. So in this case, it only exists within this block of code. So when we're trying to access it outside of the block, it doesn't work. So how do we access values that we produced in functions? This is where returning comes into play. Returning basically sends the information back to where you called the function. So the way we return the result is we use the keyword return and then the value on return. So return result. Now what this does is when you add the two numbers together, it'll send the result. So 10 plus 7 is 17, and it'll send it back to this line over here. So what we can do is we can assign a variable to it. So we can do local answer equals add numbers 10 and 7. Basically when you call it, it'll add them together and it will return 17 to this line over here, and it will assign the variable answer to 17. So I'll show you as proof. Let's say we want to add 5 to it. So answer equals answer plus 5, and we'll print answer out here. Basically what we're doing is we're creating a variable called answer and we're setting it to the return value of this function call over here. So we'll add 10 plus 7, which is 17. So it'll assign 17 to the variable answer. And now we're adding 5 onto answer and setting it back to the same variable, which is 22. So this should print 22. Oh, let's remove the print statement first. And it prints 22. Now you can even return more than one thing at a time. So let's say we want to add the numbers together, but we also want to subtract them. So we can do local sum equals num1 plus num2, but then local difference equals num1 minus num2. Now returning is useful because you can also return more than one value. So you can do return sum difference separated by a comma. Basically, to get the value outside of the function, you would have to have two separate variables as well. So local sum difference. So basically, sum would be the first variable, and then difference would be the second variable. So the two numbers are assigned separately. So 10 plus 7 is 17, and then for the difference, 10 minus 7 is 3. So it'll return 17, comma 3. So that means this variable here, the first variable sum, would be 17, and then the second variable will be 3. I can print them out separately as well, just to show you. And it prints 17 and 3. And that's everything you need to know for functions. Now on to if statements. Alright, so if statements or conditional statements are lines of code that only run if certain conditions are met. So to make things clear, I'll show you what that looks like. You start a conditional statement by typing if, and then your condition, then, and then you press enter. So what this is saying is that if this condition is met, then we'll execute everything inside this block of code. We conclude the if statement by typing the word end at the bottom. So let's say we want to check if the temperature is cold outside. To do that, we'll have a variable here at the beginning, call it temperature. We'll set it equal to 10 degrees. 10 degrees is pretty cold. And in between the if and then, we'll have the condition. So we want to check if, let's say the temperature is less than 20 degrees. If it's less than 20 degrees, it's cold, and we want to print that out. So this comparison operator here, this alligator mouth, opens its mouth to the larger number. So what it's saying is if the temperature is less than 20, then we execute the code that's inside this block. In this case, we're printing out it's cold. So since 10 is less than 20, then it'll execute the code inside this block. So we'll run this, and we see that it's cold is printed to the output window. Now there's a few comparison operators I'd like to talk about. So this one is the less than operator. You can also have the alligator mouth open on the other side. So this is saying if temperature is greater than 20. This double equal sign is if temperature is equal to 20. This operator is saying if temperature is not equal to 20. So if it's anything except 20, then the condition is met and it'll run the code that's inside. Remember, conditional statements only execute the code inside the block if the condition is true. So in this case, since temperature is not equal to 20, 10 is not equal to 20, the condition is met, so it'll run the code that's inside. You also have other operators such as the greater than or equal to. So if the temperature is greater than or equal to 20, so if it's 20 or above, it'll run this code inside. You can also switch the direction of the alligator mouth, and this is if the temperature is less than or equal to 20. Alright, but what if the temperature was not less than 20? So what if it was 30 degrees? 30 degrees is pretty hot, so what we'll do is we'll add an else statement. Basically, the purpose of the else statement is to run the code inside the second block over here if this condition is not met. So we first check if temperature is less than 20. If it is less than 20, we'll run this code inside. But if it's not less than 20, then we'll run this code inside the second block. So if it's not cold, it's hot. And we'll change the temperature to 30. So it will check if the temperature is less than 20. 30 is not less than 20, so it skips this block inside and it goes to this else statement, which runs if the other checks are false or not met. So it'll print it's hot. And that's what it shows in the output. Alright, but what if we had something in the middle? Like what if we want to check if it was warm, like not too hot and not too cold? That's what else if is for. So else if is basically providing another check for it to complete before it moves on to the else statement. So we use an else if statement by typing else if and then the condition. So the first thing we checked was if it was less than 20. Now I guess we want to check if it's less than 25. So if it's less than 25, we'll say that it's warm. If it's not less than 20 and not less than 25, then the temperature must be above 25, which is hot. So if we place a number in between, so like 24, it will first check if the temperature is less than 20, which is not because 24 is bigger than 20. So it ignores this statement over here. Then it will check the second statement. So it'll check if the temperature is less than 25. And since 24 is less than 25, then it'll print it's warm. And that's what it prints out. So this else statement over here only prints something if all the other conditions are not met. So the second one of the conditions is met, it'll ignore everything else that's below it. So if the temperature was 15 degrees, then it meets this first statement because 15 is less than 20. So it'll print it's cold. And then it'll ignore everything else that's down here. So to recap, conditional statements are to check if certain conditions are met. In this case, we wrote code that made sure the temperature was between a certain degree. We want to check if it was cold or if it was warm or if it was hot. So the else if statements are just a secondary if statement to check another condition, provided that the first one was not met. And then the else block over here only runs if everything else is false. So that's it for conditional statements. Alright, so the next topic we want to cover are tables. A table is a data type that allows you to store multiple values of any type. So we can define a table by doing local t for table, and then curly brackets. That's a table. So let's fill it up with some strings. So the different values inside a table are separated by commas. So here we have a table with 3 elements inside. Scriptix is cool, all separated by commas. So each element corresponds with an index, which is essentially its position that's inside the table. What we have here is a certain type of table called an array. An array is an ordered list of values, meaning they have numerical indexes. So to reference the position of each element, we use numbers. So this first element over here is index 1. This second value over here is index 2. And this third value over here is index 3. Now we can print specific elements of the table. So we can do print t, and to print specific elements of a table, we basically insert square brackets followed by the index. So let's say we want to print the first value, so we print t square brackets 1. So why don't you take a guess of what it'll print? If you guessed it'll print scriptx, then you're correct, because scriptx is the first element inside. So when we do t square brackets 1, it goes into the table and it looks for the first element, which is scriptx. So when we print that out, scriptx is what you see. Now, arrays have many built-in functions inside. Some of the more common ones are table.find, table.remove, and table.insert. So I'll show you how you can use each one of these. So we'll start with table.find. So table.find takes two parameters. So the first thing we want to do is we want to pass on the array. So we pass on t, and then we want to pass on the value we want to find. So let's say we want to find the value cool. What table.find does is it'll look for whatever value you provided and it'll return the index you found it at. So we can print out the result. So when we print out table.find t, cool, this function will look for the word cool inside and it'll return the index at which it found it at. So since cool is found at index 1, 2, 3, it'll print out 3. That's what it does. Now table.remove does something else. Table.remove removes a certain value from the table. So we pass on the table and then we pass on the position at which we want to remove. So let's say we want to remove the first index, which is index 1. So table.remove will go inside this table. It'll look at the index at which you provided, which is 1, so it's the first one. It'll remove the first element inside. So the table will be the same thing, except it doesn't have the first element inside. So we'll execute this function and then we'll print the table out, just so I can show you that the first element is actually removed. As you can see, the table only has 2 elements remaining, and you can see the first element we had before is gone. The last function I want to cover was table.insert. Table.insert basically inserts the value provided to the end of the table. So when we insert bananas to the array will have 4 elements. So the scriptx is cool bananas. So we'll print that out and run the code, and we can see that bananas has been added on to the end of the array. Now there's another type of table called a dictionary. So a dictionary is just like an array, except instead of using numbers as indexes, you have specific values called keys we use. So to define a dictionary, we'll just do local dictionary equals, and then the curly brackets, and I'll just press enter so we can space out the brackets so we can actually add the values inside. The keys are the names that you assign to the values inside the dictionary. So essentially it's kind of like mini variables inside the dictionary. So we'll do name. You surround the key name with square brackets, and then you type equals, and we'll write the value we want. So name equals scriptx, and then comma, and then you can have another key. Let's call it favorite color, and we'll say that equals green. And we'll have one more value that says is cool, and we'll set that to a Boolean value, true. It's true because I'm cool. So that's a dictionary. Alright, so to print specific values inside the dictionary, you have to reference its key name. So we do dictionary, square brackets, and then the key name we want. So let's say we want to print my name. So we'll do dictionary, square brackets, name. And it'll look back on the dictionary over here. It'll look for a key called name, which is this first line over here. And then it'll print the value associated with that key. So when we print dictionary, square brackets, name, it will print scriptx. Now dictionaries don't have those built-in table functions like arrays do. If we want to add a new value, like a new key inside the dictionary, we'll do dictionary, square brackets, and then the new key name. So we'll say favorite number. We set it equal to whatever we want. So let's say my favorite number is 10. What this line does is it'll insert a new key inside the dictionary. So it's essentially doing the same thing as adding a comma in and then sticking this line inside. Now dictionaries are not ordered, so when you print out the key value pairs, so name is the key and scriptix is the value. So when you print a dictionary, the keys might not be in order. So when we print out the dictionary, it might be favorite color equals green that comes first, and then is cool equals true, and then finally name equals scriptix. So unlike arrays, dictionaries are not ordered. And you can remove dictionary keys by typing the key you want. So let's say I want to remove is cool, and the way we delete the key is we set it equal to nil. Nil means nothing, so we set it to a non-existent value. So when we print the dictionary, we'll see that is cool is gone. We'll print it once before we remove the key, and we'll print it once after. So the first time we print it, we got favorite color equals green, is cool equals true, and name equals scriptix. Notice how they're not in the order that we define them in, because dictionaries are not ordered. And then the second time we print it, is cool is gone. You can see that there's only favorite color and name. Alright, so now I want to talk about built-in functions. Roblox has its own functions that they've built into Roblox Studio that are already pre-written and you can call whenever you want. So if you want to see what built-in functions Roblox has, you want to go to the Object Explorer. So you go under View and click Object Browser. So on the left panel over here, you have all the objects and instances and services that are inside Roblox. Let's say we want to browse for parts. So on the right panel here, you have all of the built-in functions that it has. You've got add tag, clone, destroy, find first child, get actor, and a whole bunch of other functions. You'll also see that it has all of the properties like color and anchored and name or material, and it has a bunch of events connected to it as well. But what we're looking at is the functions. So I'm showing you that for most objects have their own built-in functions that Roblox has already coded for you. So I'm going to explore a few of them with you here. So the most simplest one you've already seen is print, and print just allows you to print things to the output window. Another really commonly used built-in function is task.wait. And this basically pauses the script for a certain amount of time. So you would specify the number inside here. Say I want to wait 1 second, I would do task.wait 1. If I want to wait half a second, I would do task.wait 0.5. Now the next two I'm going to talk about are really similar. So you have find first child and wait for child. So let's say I was looking for a part that was inside something else. So let's say I was looking for the base plate and it's found inside a workspace. You could do game.workspace, find first child, and then in brackets you put quotation marks the name of the object that you're looking for. So game.workspace.baseplate. You can also do the same thing with wait for child. Now the difference between find first child and wait for child is that find first child will look inside the area that you specified. In this case it's game.workspace, and it will return the first object with the value you specified. So it will return the first object with the name baseplate. But if it can't find anything with that name, it will return nil. And nil basically means no value. So if I do local part equals game.workspace find first child baseplate, it will look inside workspace, it will find baseplate, and it will assign baseplate to this variable over here. Now wait for child will pause the script until it finds the object with that name. The problem with that is if there's no baseplate, it will pause the script forever and it won't continue to run. So wait for child is only good when you know that object is going to be there. So it basically waits a certain amount of time before it prints the warning that it can't find the thing you're looking for. So if I look for my cool part, basically the script will pause forever because it can't find anything called my cool part inside. It says infinite yield possible. It means the script will pause infinitely until it finds that part. But since there isn't any such part, it will pause the script forever. So wait for child is only good if you know that object is already there, or you know that object is going to be there after you call it. Alright, the last built-in function I want to talk about is getChildren. This function returns a table of everything inside the object that you specified. So say I had a folder and I put all the parts that I could see inside that folder. So let's call it my folder. So if I do local parts equals game.workspace.myfolder getChildren, it basically returns an array containing everything inside. So it's essentially the same thing as doing local parts equals spawn location, base plate, and part. So it will return everything inside the folder in the form of an array. To show you that it's true, I can print parts. So it'll go look inside game.workspace.myfolder and it'll get all its children inside. So these 3 parts over here, and then it'll put it in an array. And when I print the variable parts, it will print the array containing all 3 parts. And there you go. Alright, so the next thing I want to talk about are loops. So loops are basically these structures that allow you to repeat certain things over and over again until you tell it to stop. So the first kind of loop is called a while loop. And the way you define a while loop is you type while true do with the word end at the bottom. Basically what a while loop does is it continuously runs the code that's inside the block until you tell it to stop. So if I said print hi, the while loop will continuously print hi on and on and on forever. Now when you're using loops, it's not a good idea to leave it like this, and I'll show you why. So let's run it. It lagged my laptop massively and it tells me script timeout, exhausted allowed execution time. So basically you've kind of overwhelmed Roblox Studio because it basically prints hi so quickly it takes up all the memory. So the way you prevent it is that you add a task.wait inside. Basically it will execute the code inside the block, so it'll print hi, then it'll wait 1 second, and then it'll print hi again. That way you're not going too fast. So if I run it now, I should have no problems at all. And you can see it increases over time. I mean, you can make this number really small, just don't have it without the task.wait. Like I can do task.0.05, and it'll print hi really quickly, but not as quickly as before. And it won't crash. The way you break out of a loop is that you type the word break. So in this case it will print hi, and then it'll wait 0.05 seconds, and then it'll break out of the loop. So in this case it will only print hi once, and then it'll stop. And that's what it does. The next kind of loop is called a repeat until loop. The way you define a repeat until loop is that you type repeat, enter, and you'll see it says repeat until. So that's the structure you want to follow. So similarly to a while loop, a repeat until loop continuously runs the code that's inside the block, except that it runs it until a certain condition is met. So right after the word until is where you write your condition, kind of like an if statement. Let's say we wanted a counter and we want it to stop at 100. So we'll do local counter equals 0. We will add 1 to the counter, so we do counter equals counter plus 1. So at the first run, it'll set counter to a new value, and that new value will be itself, which is 0, and then you add 1 to it. So 0 plus 1 is 1, and then it loops again. Counter equals 1 plus 1, which is 2. So it increases by 1 every single time. Now, after the until, we'll write the condition, so we'll say until counter is equal to 100. So we want it to break when it's 100. We'll also print the value of counter to illustrate it. And obviously we want the task.wait. We don't want Studio to crash. So we'll do like every 0.05 seconds. And we'll run that. And it goes up from 0 to 100, and it should stop at 100. And that's what it does. So the until part of it kind of acts as a breaking statement. So as soon as this statement is met, we break out of the loop. Alright, so the last kind of loop is called a for loop. So a for loop is also called a counted loop because you can use it to count up numbers, kind of like what we did with the repeat while loop, but in different format. So the way you define a for loop is you type for, and then you have your variable name, so we'll call it counter, and then equals, and then it's followed by 3 numbers: the starting number, the ending number, and the increment number. So let's say we want to start at 0, end at 10, and the increment number is how much we go up or down by. So let's say we want to go up by 1. So for counter equals 0, comma 10, comma 1, we do, so write do at the end, and then enter. Basically, this for loop, it'll execute the code inside the block until the condition that counter equals 10 is met. The first time it goes through the block here, counter equals 0, and then when we get back to the top, we add 1 to counter, so counter equals 1, and then we go through the block again, and now counter equals 2, and it keeps going until counter equals 10. Now to illustrate this point, we can do print counter to show you how the counter adds up. So it starts at 0 and it goes all the way up to 10. I should also mention that it's important to put the task.wait in here as well, as for all other loops. In this case it didn't crash because we only had to go through it 11 times. Now for loops are useful because they can iterate through tables. So let's say we had a table here with a bunch of different values: Bob, Joe, Banana, Roblox. So a for loop can also go through tables. So if we want to go through an array, we can do for index value in I pairs and then the table. Basically what this does is it'll go through this table over here. And notice how we have 2 variables over here. This index value basically will print the position it's found at, and then the value variable will print the element that's at that index. So to illustrate my point, I'll print the index and then I'll print the value. The first time it goes through the loop, it prints index, which starts at 1 for arrays, so it prints 1. It'll print the value associated with that index, which is Bob. So 1 Bob, and then it goes back to the top, and it goes to the next index. So since we started with index 1, now we're at index 2. So it prints 2, and then it looks for the element found at index 2, which is Joe, so 2 Joe. And the next time it goes around, it's index 3, so it prints 3. And it looks for the element associated with that value, which is banana, and then finally it loops through one more time. It prints index 4, which is Roblox. You can also loop through dictionaries, so let's make a dictionary. So let's say we had a dictionary, we can loop through the dictionary by doing for key value in pairs. So instead of I pairs, we do in pairs, and then the dictionary name, do, and then enter. Now I'd like to make a note that the 2 variables that we have over here are just placeholders, so you can name it anything you want and it won't change anything. So we can print the value and key pairs. It's basically the same thing we did with the arrays, except that instead of having indexes as you do in arrays, you have keys, which are these things over here, which help identify the value associated with it. So when we print key and value, it will print the specific key that we're looking at, and then the value associated with that key. So we'll run that. So it prints the key, so subscriber count, and then it'll print the value associated with it, which is 285 in this case. And notice how they don't print it in order. So I wrote name first, but then it printed subscriber count first. So that's the thing with dictionaries, they are not ordered. So when you iterate through them, it might not be in the exact order that you wrote it as. Just a thing to keep in mind. And those are the 3 different kinds of loops. Now we will talk about events. So what are events? So events are basically these things on Roblox that wait for something to happen. So let's say you had a part. Now we can go inside the object browser like we did before, and we can go to part, and we can look at all the events it has. So you have changed, child added, destroying, touched, and we'll look at touched, which is the most self-explanatory one. So the touched event for a part basically fires when the part gets touched by something. So think of events like these listeners that will wait until something happens, something specific happens before firing. Events allow you to connect functions to them. So when an event fires, you can have it trigger a function. So you can get it to do something when that event is fired. So let's say we wanted to connect a touched event to this part over here. Now let's rename the part first to make it a little more specific. We'll call it cool part. So we can reference the part using a variable. So local cool part equals game.workspace.coolPart. Now the way you define an event is that you do cool part. So you write the object name dot and then the event you want to define. So coolPart.touched, and we want to have it do something when it gets touched. So we want to connect a function to it. And the way you connect a function to it is you do :connect. And then you type function, kind of like when you're defining a function, and then another set of brackets. I then remove the last bracket here and then press enter. So coolPart.touch, :connect, bracket, function, end. Basically what this event does is that it'll listen and wait until coolPart gets touched, and once it gets touched, it fires the event, which is connected to a function. So it'll essentially call the function, which is defined inside this block over here. So whatever code you have inside here will run when the part gets touched. Let's say we want to make it transparent. So we can do coolPart.transparency equals 0.5. So when we touch the part, it'll turn the transparency to 0.5. So let's play test it. So I'm here with coolPart, and when I touch it, it should turn semi-transparent because I set the transparency to 0.5. So when I touch it, it's now partially invisible. Alright, so to demonstrate my point again, we'll use a different event. This time we'll use one of the built-in events for the player service. So let's say we want to check when a player joins. So the way you do that is you do game.players, you reference the service, and then you do dot, and the event is called player added. Now you can see it right here with the lightning bolt. So when you click on it, you can see some more information about it. So it fires when a player enters the game. So we do game.players.player added, and we want to connect a function to it. Connect function, and then the end at the bottom. Now the player added event takes a parameter. So in between the two brackets after function, you can type in a parameter name. The argument that's passed is the actual player that joined. So whenever a player joins, this event gets fired, and it'll pass the player object as a parameter. And you can do a whole bunch of things with it. So I can print the player's name. So you can do player.name. I can print the player's user ID. So when I click play, I will join the game, and then this player added event will get fired, which is connected to a function. The function has a parameter called player, and it takes the player object as the argument. So when I press play, I'm joining the game, and it prints the username scriptix and then my user ID. So to recap, events are basically these listeners that wait for certain things to happen, and you can connect functions to it so that it executes code when that event gets triggered. And that's about everything you need to know for the basics of scripting on Roblox. So we've covered printing, properties, variables, functions, if statements, tables, built-in functions, looping, and now events. And if you're looking for any other tutorials, leave a comment down in the comments below. Thank you guys so much for watching, and we'll see you in the next one.